Hello, my name is Dr. Kevin Mercado. I'm a chiropractic doctor and a certified personal trainer through NASM. The purpose of this video is to describe and demonstrate balance training concepts. Three of the essential concepts of balance are static balance, semi-dynamic balance, and dynamic balance. Static balance applies to situations when an individual seeks to maintain postural control within a stationary position. An example of this would be standing on one foot. Semi-dynamic balance refers to instances when an individual seeks to maintain balance within a stationary limit of stability, yet the base supporting the body is actually in movement. An example of this is an individual riding on a skateboard. Dynamic balance occurs when a person seeks to maintain their center of mass over an ever-changing limit of stability. An example of this is an individual running on an uneven surface. Also, to add to that is the center of gravity, which is located at the approximate midpoint of the body. While the location may vary per individual, it's typically located at the midpoint of the trunk. This location can also be specified near or around the navel or belly button. When we talk about the base of support, this is the area beneath a person that consists of every point of contact between the body and the support surface. An example of this would be standing where the feet are touching the ground. This would be considered an example of a base of support. Now, there are three vital support systems within the body that help us maintain balance. These three systems include the vestibular, the somatosensory, and the sensory motor. The vestibular system provides information about the position of the body and the head and spatial orientation relative to its surrounding environment. This vestibular system that assists us with balance derives in the inner ear. An example of a movement that could throw this system off and disrupt our balance capabilities includes bending over to pick up your car key. As I bend over, I have to be able to pick up my key without falling over. So any movement of the head in space will challenge the vestibular system. Oh, shit. Even turning my head right or turning my head to the left. The somatosensory system provides information that is acquired from receptors of certain tissues of the body, such as skin, muscle, and tendons, or areas such as joints. These receptors provide the brain information about the position and motion of body parts relative to other body regions and the support surface. A great example of how the somatosensory assists us with balance is the sensation or feeling you get in the bottom of your foot when balancing on a stable surface with your shoe on, compared to the feeling you get in the bottom of your foot when balancing on a stable surface with your shoe off. Now, let's take a more in-depth view of somatosensory. We've already went over the difference between having a shoe on and going barefoot on a stable surface. Now, let's examine somatosensory on different types of surfaces, comparing shoe on to barefoot. Now, with my shoe on, the only sensation that my brain can interpret is the connection between the bottom of my foot with my sock on and the sole of my shoe. Because my shoe is on and the bottom of my shoe is the only contact point between my body and the turf, my brain cannot interpret how this turf truly feels like. However, if I take my shoe and my sock off, my brain can truly interpret correctly, allowing the bottom of my foot to truly sense what the turf feels like. Now, Let's take somatosensory and balance one step further. I can balance with one bare foot on the turf. I can go to a cushiony surface and attempt to balance with one foot on the uneven cushiony surface. I can also go to the sand, and the receptors in my skin are going to sense a different surface material. And because of that, my brain must adjust to this different sensation. As my brain interprets that, it sends information down to my foot to allow for a change in balance coordination. Even walking on the sand must activate this somatosensory system to allow me to effectively balance on this uneven surface so that I don't fall. And the last system, or we'll call it a function, is the sensory motor function. Now, the sensory motor function is the interaction between the way the body processes visual, vestibular, and somatosensory information with the motor response of the body to that information. A great example of sensory motor function is balancing on an uneven surface using a Bosu ball. This is a great example of sensory motor function being activated. The brain interprets an uneven surface while balancing on one leg, and that interpretation allows the brain to tell the body to activate increased motor coordination to allow the individual to balance with one foot on the Bosu ball. Another example of sensory motor function is performing a push-up on the Bosu ball. This is a bit more of an uneven surface compared to a push-up on an even surface such as turf. And one last system to mention that assists us with balance is our vision, or the visual system. We rely on vision quite often to allow us to know exactly where our body is at in space. An example of how the visual system works to assist us with balance looks like this. This would be a good example of challenging my visual system. And one last term that's worthy of mention is called perturbation. An example of perturbation is we have a guest appearance, future sports medicine student, Byron Bell.
What's that?
Byron is going to help us demonstrate what a perturbation is. So we're going to have Byron stand on one foot. As Byron stands on one foot, I'm going to give him a few little nudges, and I'm going to ask him to maintain his balance as I nudge him a few times. All right, Byron, so I'm going to have you try to maintain your balance as I give you a few little pushes, okay? So, good. And then I might push him from this side a little bit. I might push him from this side a little bit. I might push him from the back. And I'll ask him to maintain his balance. I might push him from the shoulders, just a little nudge. And I might just continue to do back and forth and ask him to keep his balance, all while I give him a few nudges back and forth, side to side. And that is what a perturbation is. Thanks, buddy. Yeah. Appreciate it.